Somewhere on the internet right now, there's a video claiming that a team of scientists at MIT sat down with Grok, the AI chatbot built by Elon Musk's company, XAI, and asked it a single enormous question. Why haven't aliens contacted us? And according to that video, and several others almost identical to it, circulating under slightly different titles but the same basic premise, Grok's answer was so unsettling, so far outside what anyone expected, that it left the scientists in the room stunned. I want to be straight with you before we go any further, because it matters for how seriously you should take everything that follows. There is no verifiable record of that specific event actually happening. No named MIT researcher, no published paper, no official university statement, nothing beyond a cluster of near-identical videos that all use the same dramatic language: shocked, shook, stunned, recycled across different channels and different upload dates, the exact fingerprint of a manufactured internet trend rather than a reported news story. But here's why I still think this topic is worth your full attention, and why the real version of this question turns out to be more interesting than the fake one. The question itself, why haven't aliens contacted us, is not made up. It's one of the oldest, most seriously debated open problems in modern science, with a real name, the Fermi Paradox, real physicists, who have spent entire careers trying to answer it, and a generally wide range of proposed explanations, some optimistic, some deeply unsettling, all backed by real reasoning rather than an invented chatbot conversation. So let's actually ask that question properly, the way scientists really approach it, and let's be honest along the way about what an AI chatbot like Grok can and can't meaningfully add to that conversation. The Fermi Paradox gets its name from a lunch conversation in the summer of 1950, when physicist Enrico Fermi, one of the key figures behind the development of nuclear reactors and a Nobel Prize winner, was talking with colleagues about the possibility of extraterrestrial civilizations. The math, even using fairly conservative numbers, suggested the universe should be teeming with intelligent life. Our galaxy alone contains somewhere between 100 billion and 400 billion stars, many of them considerably older than our own sun, meaning there's been ample time, billions of years in some cases, for other civilizations to arise, develop technology, and potentially spread outward, even at travel speeds far slower than the speed of light. A civilization with a modest head, start of a few million years, a blink of an eye on cosmic timescales, could plausibly have spread probes or colonies across much of the galaxy by now. And yet, when Fermi looked around at the available evidence, he found precisely nothing. No signals, no visits, no unambiguous evidence of anyone else out there at all. His famous question, simply put, was, so where is everybody? That question has never gone away, and over the 70-plus years since Fermi first posed it, scientists have developed a genuinely rich, genuinely serious set of possible answers, each with real supporters in the scientific community, each with real weaknesses that keep the debate alive. Understanding these gives you a far more substantive answer to why haven't aliens contacted us than any single dramatic chatbot response ever could, invented or otherwise. The first major category of explanation is what's often called the rare earth hypothesis. The idea that while simple microbial life might be relatively common throughout the universe, the specific combination of conditions needed to produce complex, intelligent, technology-building life is extraordinarily rare. Rare enough that Earth might be a genuine cosmic outlier rather than a typical example. This hypothesis points to a long list of seemingly lucky coincidences that made advanced life on Earth possible. A large moon that stabilizes our planet's axial tilt and therefore our climate, a Jupiter-sized planet in the outer solar system that gravitationally sweeps up many potentially civilization, ending asteroids and comets before they reach us. A planet situated in the so-called habitable zone where liquid water can exist stably on the surface for billions of years. Plate tectonics that recycle carbon and help regulate the planet's temperature over geological timescales, and a stable, long-lived star that doesn't produce the kind of violent flares that could regularly sterilize a planet's surface. Stack enough of these specific, individually improbable requirements together, and you get an argument that complex, intelligent life might require such an unlikely convergence of circumstances that it could be exceedingly rare across the galaxy, even if simpler microbial life turns out to be relatively common. The second major category is what scientists call the Great Filter, an idea that carries a genuinely unsettling edge to it, because depending on where the filter sits, it has very different implications for humanity's own future. The basic concept is that somewhere along the evolutionary and technological path, from simple, lifeless chemistry all the way to a civilization capable of spreading across the stars, there exists at least one extraordinarily difficult transition. A filter that most life either never manages to pass through at all, or manages to pass through only rarely. If that filter sits somewhere behind us, in our evolutionary past, for instance, the transition from simple single-celled life to complex multicellular life, or the origin of life itself from non-living chemistry, then humanity's existence today is a rare triumph, and we might reasonably expect to be one of the few civilizations that ever gets to look up at the stars and wonder about this question at all. But if that filter lies ahead of us, still waiting, then the silence we observe across the universe could be evidence of something considerably darker. That civilizations reliably tend to destroy themselves before they're able to spread far enough to be detected, whether through nuclear war, uncontrolled artificial intelligence, catastrophic climate collapse, engineered pandemics, or some other self-inflicted catastrophe nobody has even imagined yet. Under this reading, the universe's silence isn't necessarily comforting evidence that we're alone. It could be a kind of survivorship statistic, evidence that almost nobody makes it past a certain point, and we simply don't yet know whether we've already cleared that hurdle or whether it's still somewhere ahead of us. A third serious proposal, one that has become considerably more talked about in recent years thanks to a popular science fiction trilogy that borrowed and dramatized the concept, is often called the dark forest hypothesis. This idea suggests that the universe is silent, not because intelligent civilizations are rare, but because advertising your presence is extraordinarily dangerous, and every sufficiently advanced civilization eventually figures that out and goes quiet on purpose. The logic runs like this. In a universe where you can never be certain whether another civilization you detect is friendly, hostile, or simply so vastly different from you that its intentions are impossible to predict, and where the technology gap between civilizations could be enormous, meaning an older, more advanced civilization could destroy a younger one with ease and with little risk to itself. The safest strategy for any civilization is to stay hidden, listen quietly, and never broadcast your location to the rest of the galaxy. Under this hypothesis, the universe isn't empty. It's full of civilizations all practicing the same defensive silence, each one too wary of the others to reveal itself first, producing exactly the kind of eerie, sustained quiet we actually observe when we point our telescopes at the sky. There are plenty of other proposed explanations too, each worth a moment's consideration because they show just how genuinely wide open this question remains among serious scientists. Some researchers propose what's sometimes called the zoo hypothesis, the idea that advanced civilizations are aware of us but have deliberately chosen not to make contact, treating Earth something like a protected wildlife preserve, observing from a careful distance without interfering, similar to how human researchers try to study isolated, uncontacted tribes without disrupting their way of life. Others propose that truly advanced civilizations might transition, after some point, away from physical exploration entirely, retreating into vast simulated or virtual realities of their own creation, technological utopias so complete and so satisfying that spreading physically across the stars simply stops being an appealing use of resources, an idea sometimes called the transcension hypothesis. Still others point to the sheer, almost unimaginable scale of interstellar distances and timescales as an adequately mundane explanation on its own, arguing that even if the galaxy contains many other civilizations, the odds of any two of them existing at compatible technological levels, within detectable range, and at overlapping points in cosmic time, given that stars and civilizations have existed and gone extinct over billions of years, might simply be too low for meaningful contact to be a realistic expectation at all. No grand mystery required. Just basic cosmic statistics working against us. There's also a genuinely recent, well-documented scientific proposal worth mentioning by name because it shows this field is still actively producing new ideas rather than just recycling old ones. Dr. Robin Corbett, an astrophysicist based at NASA's Goddard Space Flight Center, published research proposing what he called radical mundanity, suggesting that any civilizations that do exist likely operate with technology not drastically more advanced than our own, lack the resources or motivation to build the kind of massive, galaxy-spanning infrastructure that would make them detectable across vast distances, and may simply have concluded, after calculating the odds, that sending out high-powered beacons meant to travel for millions or billions of years before potentially receiving any response offers so little practical payoff that it isn't worth the enormous expenditure of energy required. In other words, rather than aliens deliberately hiding from danger or being categorically forbidden from contacting us, this theory suggests something almost charmingly unglamorous, that other civilizations might simply have run the numbers and decided that reaching out isn't worth the trouble, not out of fear, but out of a kind of practical, resource-conscious indifference. Now here's where we can honestly circle back to Grok and to AI chatbots more broadly, because there is a real, legitimate way to think about what a large language model can and cannot meaningfully contribute to a question like this one. If you actually typed, "Why haven't aliens contacted us?" into Grok or into any other major AI chatbot right now, today, you would get a response. And that response would almost certainly touch on many of the exact explanations just walked through: the rare earth hypothesis, the great filter, the dark forest hypothesis, and several of the others, because these are the well-established, widely published ideas that dominate the actual scientific and popular literature on this topic, the material any well-trained AI model would have absorbed extensively during its training. What you would not get, and what no legitimate AI system, however advanced, is currently capable of producing, is some genuinely new discovery about extraterrestrial life, some previously unknown truth about why contact hasn't happened, delivered through the act of asking a chatbot a question. Large language models like Grok generate their responses by predicting patterns based on the vast amount of text they were trained on: human writing, scientific papers, discussions, books, and articles about exactly these kinds of topics. They are not connected to some hidden reservoir of cosmic truth. They have no independent access to any information beyond what already exists in human knowledge, and they cannot run new astronomical observations, conduct new physics experiments, or receive any kind of exclusive insight that hasn't already been published somewhere by an actual human scientist. This is precisely why the shocked scientist framing doesn't hold up to scrutiny, and it's worth being explicit about exactly why, because understanding this distinction matters for how you should evaluate similar viral claims about AI in the future, well beyond just this one topic. A real scientist, hearing an AI chatbot recite a well-organized summary of the great filter or the dark forest hypothesis, wouldn't be shocked, because that scientist likely already knows these ideas intimately, having read the original papers and books where they were first proposed decades before any modern AI chatbot existed. What might genuinely surprise a researcher is an AI system producing a coherent, well-structured, and accurately sourced synthesis of a complex academic topic on demand, which is a real and legitimately impressive capability of modern large language models, just not the kind of shocking new answer about aliens that a viral video title is trying to sell you. There is, however, a genuinely interesting and much more grounded way that artificial intelligence connects to this entire question, one worth spending real time on because it's actually true, actually documented, and arguably a far more compelling story than any invented chatbot dialogue. Artificial intelligence has become a real, practical tool in the actual scientific search for extraterrestrial intelligence, an effort that has been running continuously for decades under the banner of SETI, the Search for Extraterrestrial Intelligence. Researchers involved in this search have increasingly turned to machine learning models, specifically to help comb through the almost unimaginably large volumes of radio telescope data these searches generate, looking for subtle, anomalous patterns that might indicate an artificial signal buried somewhere among the vast, noisy background of natural cosmic radio emissions, patterns that would be far too time-consuming and far too subtle for human researchers to detect by eye alone, sifting through the data manually. In this very real sense, AI genuinely is already involved in humanity's actual search for alien contact, just not through the mechanism of typing a philosophical question into a chatbot and receiving a mystical reply. It's involved through the far less glamorous, far more useful work of pattern recognition across enormous datasets, exactly the kind of unglamorous technical application that tends to get left out of a viral video's dramatic thumbnail, but which represents the genuine ongoing frontier of how this search for contact is actually being conducted today. There's one more thread worth pulling here, because it connects this entire discussion back to a piece of hard, real physical evidence that actually exists, rather than remaining purely theoretical, the way most of the Fermi Paradox discussion necessarily has to. We have, as a species, only ever attempted a small handful of deliberate efforts to actively broadcast our own existence outward into the galaxy. Efforts that are directly relevant to understanding why any hypothetical alien civilization, even one relatively close to us, might not yet have had any real opportunity to detect us at all. Our first meaningfully powerful radio broadcasts only began roughly a century ago, meaning any signal we've sent outward has only had time to travel, at the speed of light, roughly 100 light years in every direction, a genuinely tiny bubble compared to the sheer scale of a galaxy that stretches over 100,000 light years across. Even if a civilization exists just a few hundred light years away, well within our own galactic neighborhood by cosmic standards, our own radio signals may simply not have reached them yet. And any signal or acknowledgement they might eventually send back would still take that same span of years to reach us in return, meaning the practical timeline for any realistic exchange, even in the most optimistic scenario involving a genuinely nearby civilization, could easily stretch across centuries rather than concluding within any single human lifetime. That's not a mysterious cosmic silence born of aliens hiding from us or ignoring us out of indifference. That's simple, well-understood physics, the finite speed of light working exactly the way Einstein's equations say it should, applied honestly to the very real, very short amount of time humanity has actually been capable of sending or receiving these kinds of signals at all. So here's the honest, complete answer to the question this video title poses, stripped of its invented drama, but I'd argue considerably more satisfying once you actually sit with it. Nobody asked Grok this question in some dramatic, MIT-sanctioned unveiling that left a room full of scientists stunned into silence. And if you did type this question into Grok yourself right now, you'd get a well-organized, accurate summary of exactly the ideas we've just walked through together. Not a shocking revelation, because no chatbot currently has access to any information about extraterrestrial civilizations beyond what human scientists have already published and openly debated for decades. But the real question underneath the fake headline, "Why haven't aliens contacted us?" remains one of the most genuinely fascinating open problems in all of science, with serious, well-reasoned, and sometimes genuinely unsettling possible answers, ranging from the reassuring that complex life might simply be extraordinarily rare, to the deeply sobering that most civilizations might not survive long enough to spread beyond their home world at all. And the actual, real involvement of artificial intelligence in this story isn't a chatbot delivering a cryptic warning. It's a quiet, practical, and genuinely valuable tool helping human researchers sift through mountains of telescope data in the ongoing, decades-long, entirely real search for a signal that, as of today, we still haven't found. Whether that silence means we're rare, means we're early, means we're being deliberately left alone, or simply means the universe is too vast and too old for any two civilizations to ever likely cross paths at all, remains one of the great open questions of our time, and it deserves to be taken seriously on its own considerable merits, without needing an invented chatbot conversation to make it feel important. It already is. Let's spend a little more time on the actual documented history of humanity's real attempts to reach out, because it adds important context to why the silence we observe isn't necessarily as mysterious as it first appears, and because these efforts are genuinely fascinating in their own right. In 1974, astronomers at the Arecibo Observatory in Puerto Rico transmitted a deliberately designed radio message toward a cluster of stars called M13, roughly 25,000 light-years away, encoding basic information about human DNA, our solar system, and the numbers 1 through 10, using a simple binary format designed to be at least theoretically decodable by any sufficiently advanced recipient. Because of that enormous distance, the message won't even arrive at its destination for another 20-plus millennia, and any conceivable reply would take another 25,000 years beyond that to reach us, a timeline so vast it renders the entire exchange more of a symbolic gesture toward the deep future than any realistic attempt at a conversation. NASA's Voyager probes launched in 1977 and still, remarkably, transmitting data back to Earth from interstellar space today, each carry a golden record, an actual physical phonograph disc encoded with sounds and images of Earth, greetings in dozens of human languages, and samples of music ranging from Bach to Chuck Berry, intended as a kind of interstellar time capsule in the highly unlikely event that either spacecraft is ever recovered by another civilization, drifting silently through the emptiness of space long after human civilization itself may have changed beyond recognition. These aren't science fiction ideas. They're real, physical, still ongoing efforts, and they illustrate just how genuinely difficult, slow, and uncertain any real attempt at interstellar communication actually is a far cry from the instant, dramatic exchange implied by a chatbot supposedly answering a question about alien contact in real time. It's also worth understanding in a bit more depth how the actual scientific search for alien signals works today, because the real infrastructure behind the search is impressive in its own right, and it's been running for a lot longer than most people realize. The modern SETI effort traces back to 1960, when astronomer Frank Drake conducted Project Ozma, pointing a radio telescope at two nearby sun-like stars in the hope of detecting an artificial signal, an effort that famously found nothing but helped launch a scientific tradition that continues in expanded form to this day. The SETI Institute, along with the Breakthrough Listen initiative, a well-funded decade-long project launched in 2015 with backing from the internet investor Yuri Milner, now uses some of the world's most powerful radio telescopes, including the Green Bank Telescope in West Virginia and Australia's Parkes Observatory, to systematically scan large portions of the sky across a wide range of radio frequencies, generating data at a scale that would have been utterly unimaginable to Frank Drake back in 1960. This is precisely where modern machine learning tools have become genuinely essential, not as some mystical oracle answering philosophical questions, but as a practical necessity, because these telescopes now generate such enormous volumes of raw data that manually reviewing all of it for potential anomalies would simply be impossible for any team of human researchers, no matter how large or how dedicated. Machine learning models trained to recognize the specific signal characteristics that would distinguish an artificial transmission from ordinary background radio noise, cosmic radiation, satellite interference, and other naturally occurring phenomena have already been used to reprocess archival SETI data and flag candidate signals worth a much closer, more careful human review. Exactly the kind of practical and glamorous application of artificial intelligence that actually deserves genuine credit in the story. There's a broader lesson buried in all of this that's worth carrying forward, well beyond just this particular topic, because the exact same pattern shows up again and again whenever a viral headline claims an AI chatbot has produced some kind of shocking, unprecedented answer to a big question. Large language models like Grok are, at their technical core, extraordinarily sophisticated pattern matching and text generation systems, trained on enormous quantities of existing human writing, and genuinely skilled at producing fluent, well-organized, contextually appropriate responses to almost any question you might ask them. That is a real, impressive, and legitimately useful capability, one worth appreciating on its own terms. But it is fundamentally different from an AI system possessing some kind of independent access to hidden truths, private data, or exclusive cosmic insight unavailable to the rest of humanity. When a chatbot produces a well-structured answer about the Fermi Paradox, it is doing something similar to what a well-read graduate student might do if asked the same question on the spot, drawing together the existing, published body of human knowledge on the topic into a coherent summary, not channeling some previously unknown truth about the universe that no human scientist had ever considered before. Understanding that distinction matters for a reason that goes well beyond this single video and this single topic, because this exact same AI was asked X, and its shocking answer stunned everyone template has been applied, almost interchangeably, to dozens of different big, mysterious-sounding questions across different viral videos, quantum computers and the nature of the universe, AI chatbots and the existence of consciousness, artificial intelligence and predictions about humanity's future, each one following the identical dramatic structure, each one typically thin on verifiable sourcing, and each one relying on the basic, understandable human fascination with the idea that a sufficiently advanced machine might somehow shortcut its way past the slow, patient, uncertain work of actual scientific inquiry. Recognizing that pattern doesn't mean dismissing every claim about AI capabilities out of hand. Modern AI systems genuinely are remarkable, rapidly advancing tools, and entirely real, well-documented breakthroughs in AI research happen regularly and deserve serious attention. It just means applying a healthy, consistent standard of evidence. Is there an actual named source, an actual publication, an actual verifiable event behind this claim, before accepting that a chatbot has produced some kind of genuinely shocking new revelation about the biggest questions humanity has ever asked? So, if you came to this video hoping for a cryptic, unsettling answer typed out by an AI about why aliens haven't found us yet, I hope what you found instead feels like a fair trade. Not a shortcut past decades of real scientific work, but an honest tour through what that real scientific work has actually uncovered. The genuinely rich, still unresolved debate among astronomers, physicists, and biologists about the rare Earth hypothesis, the Great Filter, the Dark Forest, and the many other serious explanations for the profound silence we observe every time we point our telescopes at the sky. That silence remains one of the most fascinating open mysteries in all of science. Not because a chatbot said something shocking about it, but because 75 years after Fermi first asked his simple question over lunch, nobody, human or artificial, has yet found a definitive answer. And the honest, patient search for one continues, right now, in radio telescope data being sifted through by scientists and their AI tools alike, somewhere out there in the vast, quiet dark. And maybe that's actually the more comforting thought, once you sit with it long enough. We don't need an invented chatbot conversation to make the universe feel mysterious. It already is, genuinely, honestly, on its own terms, filled with billions of stars we've barely begun to study, a silence we still can't fully explain, and a search for answers that real human beings, using real telescopes and real tools, including the AI models built to help sift through the data, are still actively conducting today. The next time you see a headline promising that an AI chatbot has uncovered some shocking secret about aliens, consciousness, or the nature of reality itself, it's worth asking the same simple question a good scientist would ask. Where's the actual source? And is there a real discovery here at all, or just a very old, very human question, dressed up in a new, machine-generated costume?